So division, when we want our answer to be a decimal, can sometimes get awkward. Typically in decimal division, we keep going until either there's no remainder or we see that we have a repeating decimal. And sometimes we just don't want that much precision. Sometimes all we really care about is an answer rounded to the nearest tenth or the nearest hundredth or the nearest thousandth. And when that's the case, well, remember, when we're rounding, we only look at the place we're rounding to and the following digit, which means that once we know about that digit, we can stop dividing, which in the future is going to make us very, very happy. This also applies to whole number division, though we didn't talk about it then. If I'm doing some very, very long division and I want to round my answer to the nearest thousand, I only need to continue until I know what digit is in the hundreds place, for example. So let's see an example of how this works in play. Let's suppose we wanted to divide 106 by 7 and round our answer to the nearest tenth. So I'll be dividing 7 into 106 point. I know I'm going to round my answer to the nearest tenth. So I'll want to work out what's in the tenths place, but also what's in the hundredths place, so I know how to round. So what I've done is, I know I will want to work until I get to the hundredths place and no further, so I've written in all of the zeros I'm going to need to add beforehand. If it turns out I don't need these zeros, well, then I don't need them. I'll just write zeros in whatever places I don't need to deal with. I've also marked the tenths place where I'll round to, and the following place that I'll look at. The reason I've done all of this in advance is that once I'm doing the long division, I'm going to have a certain rhythm going. And I want to already have marked on my piece of paper where I'm going to stop, so that I don't need to keep pausing and saying, can I stop yet? Can I stop yet? I'll know I can stop when I've written a digit in this place. So, we divide. 7 goes into 1, not at all. It goes into 10 once. 1 times 7 is 7. 10 minus 7 is 3. Bring down the 6. 7 goes into 36 5 times. 5 times 7 is 35. Subtract. 1 remains. Bring down the first 0 I've written in. 7 goes into 10 once. 1 times 7 is 7. Subtract. 3 remains. Bring down the first 0. 7 goes into 34 times. And now that I've written this digit, I can stop. As long as I know that 4 is the right number to have here, I don't even need to fill in 4 times 7 down here. I certainly don't need to do the subtraction. I can stop at this point. Why? Because I know what this digit is, and I don't need to know any more than that about this quotient. I want to round to the nearest tenth. This is between 15.1 and 15.2. This 4 here tells me that I'm closer to 15.1. I'm going to give you one of these to try now. Divide 82.4 by 23. Round your answer to the nearest thousandth. Pause the video and try this now. Alright, so I'll be dividing 23 into 82.4. I'm going to want to round my answer to the nearest thousandth. So So I'll fill in all of the zeros that I'm going to need. Here's the tenths place, the hundredths place, the thousandths place. This is the place I'm going to round to. I also need to know what digit goes in the 10,000ths place. If you were having trouble getting this set up, this is the correct setup. Pause the video and complete the division. All right, so 23 goes into 8, not at all. It goes into 82 at least once. Let's see how many times. I think that 3 is probably a good guess. 23 times 3. Well, 3 times 3 is 9. 3 times 2 is 6. Maybe it goes 4 times. 23 times 4. 4 times 3 is 12. 4 times 2 is 8, plus 1 is 9. Oh, 4 is too much, so it's going to be 3. 3 times 23 is 69. Subtracting, I'll need to borrow. 12 minus 9 is 3. 7 minus 6 is 1. Bring down the 4. Well, 4 would be too small. Let's try 6. 23 6 times. 6 times 3 is 18. 6 times 2 is 12, plus 1 is 13. 6 is just a tiny bit too big, so it's going to have to be 5. 5 times 3 is 15. 5 times 2 is 10, plus 1 is 11. 5. 115. Subtracting, I need to borrow. 14 minus 5 is 9. 2 minus 1 is 1. Bring down this first 0. 23 in it to 190. It looks like 6 is probably too small. Let's try maybe 8. 8 times 3 is 24. 8 times 2 is 16, 17, 18. Yeah, 8's going to be my guess because 9 would get me past 190. 8 times 23 is 184. Subtract. I'll get 6. Bring down this next 0. I see 3 is going to be too big, so must be 2. 23 times 2. 2 times 3 is 6. 2 times 2 is 4. So 2 times 23 is 46. Subtracting 1 minus 6 is 4. 10 minus 6 is 4. 5 minus 4 is 1. 23 must go into 146 times. And now I stop. Right, because I'm rounding to the nearest thousandths. This number is between 3.582 and 3.583, and the 6 in the next place tells me to round up. Oh, notice, by the way, that this rounded answer, it's not the exact answer, right? So if we were to multiply 3.583 times the 23 we divided by, we expect to get something that's close to 82.4, but not exactly 82.4. Let's see what we get. Let's see what does happen when we do this multiplication. 3.583 times 23. 3 times 3 is 9. 3 times 8 is 24. 3 times 5 is 15, 16, 17. 3 times 3 is 9, plus 1 is 10. 2 times 3 is 6. 2 times 8 is 16. 2 times 5 is 10, plus 1 is 11. 2 times 3 is 6, plus 1 is 7. Adding those up, we'll have 9, 10, 14, 2, 8. 1, 2, 3 digits to the right of the decimal point. 82.409. Not exactly 82.4, but very, very close.